Math time. So we're going to start a new unit today. It's on volume of three-dimensional shapes. So the way this video is going to work, we have three different shapes. We've got cylinders, spheres, and cones. I'm going to go over each one. It's a little mini lesson thing. It'll take about 3 minutes. All right. So we're going to get started with a sphere. No, we're not. We're going to get started with a cylinder. Yeah. Okay, so a cylinder, in case you just need a quick refresher, putting name to shape, a cylinder is basically a can or a cup. This here's a cylinder. It's got a round top and then a straight side down the side. When you find the volume of a cylinder, okay. The formula for finding the volume of a cylinder is pi times radius squared times your cylinder's height. So if you remember back from 2 weeks ago, this is a little bit similar to the area of a circle. We've got pi times radius squared. So that pi times radius squared means the top of this cylinder right here, you find the area of the top of the cylinder, which is a circle, and you multiply that area times the height of your cylinder. And that will give you your volume. One thing where you can kind of think about it is when you're finding the volume of something, specifically a cube or a prism or a cylinder, you're finding the area of the base, and then by multiplying by the height, you're effectively layering multiple bases on top of each other to create a stack, kind of like a stack of pancakes. One pancake, if you think of that as just a circle, you stack a few on top of each other, you have a stack of pancakes, that's a cylinder. So with this example right here, I've got a cylinder with a radius of 3 and height of 5. Notice these are in centimeters. So what we do is we take our numbers and we just throw them into our formula. Again, our formula is pi times radius squared times height, or pi times radius squared, which is the area of the circle at the top, multiplied by the height of our cylinder. So let's do some numbers here. You're gonna have to hang on with me. This is kind of an awkward thing to write with. Okay, so our first step, we want to identify what our values are. I've already got them right here. R, or radius, is 3 centimeters, and our height is 5 centimeters. We're gonna take those numbers, throw them in to our formula. So if I rewrite the formula, we get pi times 3 squared times, what did I say, 5. All right, put our little multiplication dots in there. Okay. If you remember back real quick, pi is the same thing as 3.14, at least for right now, so that's fine. I'm going to simplify this a little bit. We're going to do pi times, let's see, 3 squared is 3 times 3, which is 9, times the height, which is still 5. Now you can solve this in any order you want because it's all multiplication. I'm just going to do pi times 9, or 3.14 times 9, which is 28.26. We're still got to multiply by 5. All right, 28.26 times 5 is 141.3 centimeters. All right, and then this is something that's just a little bit tricky, and I want to get through everyone's head. When you're measuring a distance, you just put whatever your initial unit is. So in this case, it would be the radius of this circle right here is 3 centimeters. Radius is 3 centimeters, height is 5 centimeters. That's just a measure of distance. When you're measuring area, you're measuring in units squared. So the area of this circle is 28.6 centimeters squared. But when you're measuring volume, you need to measure it in a 3-dimensional unit, which means you're measuring it in units cubed. So this is 141 centimeters cubed, which is raised to the third power. The reason you deal with cubed is because you're dealing with three-dimensional shapes, so it's got length, width, and height. That's just something to keep in mind. Whenever you do volume, you're dealing with units cubed. So the second shape we're going to look at is a cone. I don't have a cone laying around the house. They're not very common. But obviously, things that come to mind are like ice cream cones and ice cream cones. It just snowed again. Anyway, so to find the volume of a cone, it's very similar to the way you find the volume of a cylinder, except there's one little difference. And before I get to that, I want to show you a real quick section of a video, just kind of prove my point. Okay, so before I click this video, things you should know. The top of the cone is identical in size to the top of the cylinder right here, meaning they have the same radius and they have the same height. You measure the height of a cone by the side. You measure the height of a cylinder from the side. You measure the height of a cone from the center straight up the middle. All right, that's something to be a little cautious of. This line right here is not the height. Height of a cone is measured from the center, from the tip right here to the center of the base, or the top, depending on how it's oriented. Anyway, these two shapes have the same height and the same radius. Okay. This is what I want to do in the classroom, but obviously I can't do that. These are hollow, so you fill the cone with water. Thusly. You'll notice that the cone does not fill up the cylinder, not even halfway. Still more room. And just barely makes it. Okay. So just to recap, the first cone filled the cylinder up about yay high, second cone filled it up about yay high, and then third cone brought the volume of the cylinder right up to maximum. Thank you, MooMoo Math and Science, for the video. I did not ask permission. So that means that the volume of a cone is 1/3 the volume of a cylinder. All right, let's get into the model right over here. Okay, so what we got right here, 1/3 pi radius squared times h. You'll notice that this right here is the same thing as the volume of a cylinder. We got 1/3 pi squared h. Okay, same as before. Our height is 5. Notice that I measure the height straight through the center of the cone. My radius here is 3. So if you remember back to the problem beforehand, when we plugged 5 in for h, 3 in for r, we ended up with a volume of 141.3 centimeters cubed. That would be the volume if this was a cylinder. This is a cone, so we need 1/3 of it. So you can either multiply by 1/3 or divide by 3. They're the same thing. So we take the volume here divided by 3, and we end up with a volume of a cone, which is 47.1. This is worse than what I'm actually writing on the board. 47.1 centimeters cubed. All right. So thing to remember, when you're finding the volume of a cone, it's the same thing as finding the volume of a cylinder, except you multiply by 1/3 or divide by 3. Okay, So our last shape is the most complicated. That is a sphere. A sphere is a ball. So you think like a soccer ball, a baseball, mail order Death Star, an eyeball gouged out by a werewolf, a ping pong ball. All of those things are spheres. And a sphere has got the most complicated formula. So you're really going to want to write this one down. Make sure you use your notes, and I'll try to explain it kind of as we go along. But the formula for a sphere is 4/3 times pi times your radius cubed. So in case that doesn't make any sense, let's take a look at my online whiteboard for a moment. Okay. So right here we have 4/3, which is the same thing as 1.33, multiplied by pi times your radius cubed or raised to the third power, which means it's radius times radius times radius. All right. The saving grace of this particular formula is that you only have one number you have to plug in. That's your radius. There's no height measurement on a sphere. Other thing I want to quickly draw your attention to is when drawing a sphere, it's relatively hard to try to make it look three-dimensional. So you'll oftentimes see it as a circle with basically an oval right down the middle, denoting that there is another circle going on a different plane, kind of cutting your original circle in half roughly. And your radius is measured from the center of your sphere out to the edge. In this case, my radius is 3. Okay, so in order to solve for the volume of this sphere here, I take my radius, plug it in here, and then solve best I can. So we're going to go 4/3. So what we're going to do is we're going to take our radius, we're going to plug it in or substitute it in for the r value in our formula right here, and that way we're going to be able to solve for whatever the volume of the sphere is. So we're going to start with 4/3 in parentheses pi 3 to the third power. Okay, so 3 to the third power is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we can rewrite this as 4/3 times pi times 27. All right. Pi times 27, remember that pi is 3.14, so that is going to be 3.14 times 27, 4/3 times 84.78. Great. Okay, and our last step is multiply 84.78 times 4 1/3, or 84.78 times 1.33, and our total is going to be 113.039 centimeters cubed. Because again, we're dealing with volume, so everything is cubed. All right. That should do it. All right, that is the end of this lesson. I know it's very heavy on formulas. My suggestion is take a good look at that note sheet. They're all written out there for you. The thing to remember is you take whatever your radius value is and you plug it in for the r value in your equation. You take whatever your height is and you plug that in for the h value in your equation. And then it's basically just solving like any other equation that we've been doing in math class all year long. If you have any questions, feel free to email me. And also come to the office hours. They're Tuesday through Friday from 12 to 1. All right. Have a fantastic day. All right. Okay. The volume of a cone is found very similar to the volume of a oh god. Start over.